Today we're very pleased to have with us Murat Kaselli from the Argonne team, and he's going to speak about JupyterHub today. And without further ado, I'll hand you over to Murat.
Thank you, Ray. So today, this webinar will be about ALCF JupyterHub. This is a new service we had at ALCF, and I will describe how we can achieve interactive computing by using ALCF JupyterHub. So here's a brief outline about what I'm going to talk about. So I will start with describing the project Jupyter, what you can do with Jupyter Notebooks, Jupyter Lab, and other Jupyter features. And then I will describe basics of Jupyter, how it evolved from IPython, like how you can use Markdown, Magic, IPython Magics, and Jupyter widgets. And then I will introduce the ALCF JupyterHub. And the rest of the presentation will be live demos. I hope it will go all right. So I will describe how we can install a new kernel on JupyterHub, how we can submit jobs to our queue manager. And then I will describe about a workflow manager called Balsam briefly, how you can use it again on JupyterHub interactively. So before going into the talk, I will have to give a disclaimer about what we are not going to cover today. So there won't be any low-level details about how you can queue the jobs, best practices for that, how you can set the memory mode to get higher performance on the nodes, or how you can ensemble jobs, etc. These were actually covered in a previous webinar. You can find on the ALCF, and you can find this link. All the slides will be shared. You can. We are not also going to discuss about how you can use Jupyter through an SSH tunnel or reverse proxy or remote kernels. While this is possible to do, it may not be as reliable as using JupyterHub. Your connection might drop, and it can create more headache than you would like. Other approaches like using Dask, Spark, Kubernetes, or containers for distributed computing and accessing computer nodes directly will not also be discussed, as these are not supported officially, and it's really not reliable at this point. You need to put lots of effort to make them work. But hopefully we will have these available as a service in the future. So ALCF JupyterHub is a relatively new service and improving rapidly. So if you have any questions, any problems, please send the support team an email. And if you can CC me, I would be happy to provide feedback. Okay, so let me make another note. So we are going to talk about interactive computing. I would be really happy if you have any comments during the talk, so we can also make the talk interactive. So that will actually enhance the engagement here. Okay, that said, I will start with the project Jupyter. It is basically a spin-off project from our Python project, which is basically trying to make Python more interactive. The project was led by Fernando Perez, and his motivation was he wants to develop open source software and open standards, like how Python is, how Julia is, and how this scientific software is available to all of us right now. So he also mentions that he's inspired by Galileo's notebooks. And here on the left, it's a bit small, but you can see the scan of his famous notes. And here he is actually describing Jupyter's moons. So in these notebooks, he has equations, he has plots, he has sketches. So basically, Fernando Perez's motivation was to provide scientists a tool just like Galileo's notebook, and a digital tool that scientists can use and develop code and develop their scientific workflow inside it. And originally, Jupyter started supporting Julia, Python, and R, but right now actually it is supporting almost all the languages, most of the languages at least. You can see the Jupyter kernels that here I will provide a link where you can see all the possible languages that you can run Jupyter with extensions. So Jupyter notebooks evolved into different projects. Actually, the next generation is JupyterHub, and it has very nice features. You can also execute your Jupyter notebooks, but the layout, you can be more flexible here. You can have tabs. You can create your own dashboard using a JupyterHub. A JupyterHub is where users can use Jupyter notebooks from a server and then access the whatever it's the cloud services or high performance computing centers. And very recently, in this year, in August, I think, Jupyter Book is announced. So this is enabling people to develop interactive books. So these are all nice features related to Jupyter. But I will mainly cover Jupyter Notebooks today. So what you can do? Well, as I mentioned, this provides you an interactive development environment. You can prototype your code, test ideas very easily. And here, you can click the link when you have the slides. There is this Jupyter kernels list, and you will see that many languages are supported. And you can learn or teach with notebooks. This is actually very useful. Nowadays, you will find any machine learning tutorial is given as a Jupyter Notebook file. And you can run your data analysis and visualization. And we also have another webinar, actually. The previous webinar was on data analysis and visualization. So if you want to learn more about that, please check out that webinar. And you can also even present slides. Currently, I am actually using Jupyter Notebook to prepare these slides. And the main topic will be the interactive work on HPC centers or cloud, like JupyterHub or Google Colab, or binders on which basically turns your repos into interactive, turns the notebooks in your repos to be executed on the cloud. So, okay, this is just to give you an overview, like what you can do with Notebook, because these shortcuts actually make your life easier. Jupyter is all about making your workflows easier. And if you use these shortcuts, if you are coming from more oriented with using terminal, the command line features, you will find that Jupyter has lots of useful shortcuts. You can also edit all of them. So if you click H, you can see all these shortcuts, and it is really easy to modify these shortcuts as well. And I find them very useful. You can, if you are, for example, very advanced on Vim or Emacs, you can even install some extensions so that you can use Vim shortcuts or Emacs shortcuts as well. So for example, I can just demonstrate here by typing. So one thing you need to be careful is when it shows green, you are in the edit mode. When you press escape, you will go into the blue, and this will be the command mode. And within command mode, for example, by pressing A, I can create a new cell, and by double this, I can delete it. By typing C and then V, so here I can show. You see that it is copied here. And other useful features is basically tab completion is another useful feature I use a lot. So like as in your, so let me go back. So after you import the module, you can basically use tab completion and figure out the function or the module that you are interested in. And another cool feature is by pressing, if you type tab more, or by typing question mark and then executing the cell, you will also see the signature of the function that you have. If mainly this happens if the code is in Python. So you can find the docstring and what the parameters are. And even more, if you put 2 question marks, you will access the source file. So this is the source is very simple, just returning this variable. These are very useful features that will help you when you are using Jupyter Notebooks in general. So going Okay, just a second. Okay, sorry, this another feature is basically you can use markdowns in cells. Basically, you can convert a cell into a code cell or a markdown cell, and there are other options as well, depending on your extensions. And within these, when you use markdown, if you are familiar with it, you can have equations, you can have images, you can have tables, you can provide links. So it is really useful. I'm not sure why this break. Okay. Okay. So another useful feature is IPython magics. And while these were evolved in IPython, these are all available in Jupyter. These magic functions are prefixed by a 1% sign if you are using a line magic, which will apply only to a single line, or if you use double % signs, then you will get the cell magics, and these cell magics as a constraint that they should be on the first line. You can also use shell comments by prefixing them with an exclamation mark. So to learn more about line magics, you can look at this quick graph. You can also check magic by simply executing these magics here. You can get useful features like debugging. You can report time, profile your cell. And here, for example, I can demonstrate this. Here you can see the information about the magic functions given in all the detail. And note that I didn't install anything. These are all available when you install Jupyter. Or, for example, this is a very basic demonstration of how you can use time-it. Here we have a very simple array of just numbers. We can use Python's native sum and then sum all the values. We use NumPy's sum, and we can then convert the array into NumPy array and then use NumPy sums, and we can compare the timings. And what you will see here is you will see that if you use native sum, you will have a much faster loop rather than NumPy using the regular Python array. But if you convert it to a NumPy array, you will be even faster. So these were all about Markdown and magic. Another feature is widgets. Widgets are basically graphical user interface elements that basically enhance your interactivity on Jupyter Notebooks. You can use sliders, text boxes, buttons, and many other features available. So these are just basic widgets like slider, text, or buttons. So let's come to the main topic, the ALCF JupyterHub. So if you are an ALCF user, you can simply log into this link, jupyter.alcf.nl.gov, using your ALCF credentials. The password and everything is same as how you log into Theta, but now you have a graphical user interface. Type your username and password here. And we have basically, and note that these JupyterHub instances are run on external servers. They are not run on Theta or Cooley, our ALCF machines, login mom or compute nodes. These servers are good servers, like they have 500 GB memory, but still they are not for any compute intensive operations, not for simulations, definitely. But you can submit jobs through JupyterHub, which I will describe in this presentation. And ALCF JupyterHub basically exists for now for our two machines, for Theta and Cooley. One thing to note is that both instances have access to your home folder, but the project folder's access is different. On Cooley, you can access both Theta project folder and the previous machine's Mira project folder. And Theta can only access the Theta projects folder. And note that these machines do not have any access, you do not have any access to specific Cray libraries that exist on Theta. So this sort of limits about how you can install stuff, because you need to install using what is available on these machines. But you can still submit jobs and you can still use these servers very efficiently. And if you install things on your home directory, they will be available for both to use in both instances. Some things to note. So JupyterHub basically starts on your home folder. You will see sort of a file browser where you can create a Jupyter Notebook, or you can create a terminal. But note that you will not access directly your project folders. To have an access, you need to create a symbolic link. Then on your home folder, then you can get access. And note that if you have a broken link, this happened to me. JupyterHub basically gives an error, and you cannot open the page. So, I mean, you cannot even open your home page. So for that, you need to clean up all your broken symbolic links. Another failure might be related to your quota. As you will see, when you have lots of Conda environments, on your home, you will exhaust your quota very quickly. Check your quota with my quota. When you exceed your quota, you may also have problems in accessing JupyterHub. And you can also currently run JupyterLab also, although we run an earlier version of it, which will be updated soon, by simply modifying the link. In the link, you will see a tree. You need to, unfortunately, cut the tree and put a lab there, and then you will access the JupyterLab. And more documentation is available at this address. Okay, so now I will briefly overview how we can install a Jupyter kernel, but I will also show a live demo about it, so I will try to pass this part quickly. So the first step would be you have to check what are your existing environments and kernels. So because you might be using Conda environment on Theta or Cooley, you may have native Conda environments there, but we want to install Conda environments specific for our Jupyter. So check your environment list, check your current Jupyter kernels, and then select a name. What I generally use is I use jhub underscore as a prefix so that I can distinguish JupyterHub environments from others. And after you select your name, so basically one cool thing about Jupyter is once you select and define this Python variable, you can use that Python variable within the shell magic. So here I'm showing an example. This name will be picked up from your Python environment and put into here. So you can create an environment directly like this. If you want to change the Python version, currently we have Python 3.7 on JupyterHub as default, but you can change it by installing a different version. However, if you are okay with Python 3.7, I would strongly recommend cloning the base installation on JupyterHub, because we have lots of modules already installed, which may be difficult for you to install. So if you clone the base, you will have access to all of these modules, all of these packages. So I will suggest start with cloning the base. And at this step, I need to warn, if you want to change the environment name, unfortunately, Conda right now does not provide a simple renaming function, so you need to remove your environment and then restart. But hopefully you don't need it if you pick carefully. Next step would be basically installing the packages that you need. So you can use either Conda or pip. Mostly Conda might be preferred, as we are doing everything on a Conda environment, but both should work fine. So you install Conda. Don't forget to put -y here in Conda, because it's going to ask you to enter, and you cannot, within a shell environment, you cannot basically answer the question interactively like that. So you have to put -y here, or you can put everything into the terminal. You can, as I mentioned, you can open a terminal within JupyterHub as well, and you can, without the exclamation mark, just like what you do on a regular terminal, you can type these commands. And note that if you didn't clone from the base, you need to install Jupyter and Conda and IP kernel packages as well. And the last step, and last but not the least, because this is really important, otherwise you won't have the Jupyter kernel associated with the Conda environment. So you need to install the IP kernel, basically, which is a Jupyter kernel. And I use the same name as my environment with the kernel. You may choose differently, but I think this is useful. So finally, after this is completed, you need to refresh your browser or just open a new notebook. And then if you look at the kernel from the top-down list, you can select it, you can find the new kernel and you can select it. And then basically you can run whatever application you want to run. And when you need to include other packages next time, you just need to remember the mname and then install the package. You don't need to install the kernel again. Some notes, after installing, you can check with Conda list what packages you have. And for the specific package you have, just try to import it. And after importing, check this .__ file, because you need to make sure that the file, you are picking the right, and you have the right version. And note that do not use the environments installed on JupyterHub directly on your job submitted on Theta and use that environment, because that environment is mainly using the JupyterHub server's environment, so they will not be useful for that. This will be useful for you to run JupyterHub. And as I mentioned, you may run out of space quickly if you are installing on your home folder, and which is sort of suggested here. Check your space with mycota. Obviously, you can put an extra. So you can run conda clean to clean up your environment, to clear up the cache. And finally, if you don't want to uninstall some packages, you can use this removal. And you can also uninstall the kernels like this, or you can simply remove the kernel directory. So these are some resources that you may find useful. You can check out a new feature from Jupyter Voila, which basically turns into your Jupyter Notebooks into an executable, standalone executable. Jupyter Lab, as I mentioned, is basically the next generation of how to use Jupyter Notebooks, and Jupyter Books. There are actually many nice Jupyter tools, but I picked one that I find very useful. One thing that that is not very good in Jupyter Notebooks is to provide version control. When you put on GitHub, since all the notebook is stored as a JSON file, it may be hard to find the diffs of what you have edited. But there is this tool, mbdime, I think, that you find in the link that will be very useful for that. And we have many useful tutorials for machine learning or for other applications, which you will find on these links. Okay, before I go to live demo, since I don't know what will happen then, I would like to provide the acknowledgements. First of all, thank you for all, and please stay. I will continue with demo. I would like to thank Misha, Alvaro, and Andre for their suggestions. Tommy Jackson is the guy who is running and maintaining our Jupyter service. He is the hero behind the scenes. And I had a summer intern, Gurunat. We worked very nicely during the summer on JupyterHub. And I would like to thank Venkat, Tom, and Mike for motivation and support. So with that, all the materials about the live demo is available on this GitHub address. And you can run everything on JupyterHub right now, and I will demonstrate how to do that.
So one question, are the slides there as well?
Slides are there, but not the latest version, so I will update them and put them. Slides are provided as a Jupyter Notebook. I will also add a PDF.
Yeah. Okay, thank you.
Are there any questions so far? I will wait for 10 seconds. Please speak up, and I will check the chat button. So I guess I hear silence. So okay, I will go to our demos. So first, I will start with installing.
I put a few questions on the chat if you don't mind, Murad, to look at them.
Ray, could you help me about the question? I couldn't. Oh, okay, I find.
I'm sorry. What was the question?
Okay, I see the question now. There are questions on the.
Yes.
Yes. So you can. Okay, first question is how you can share a notebook with a collaborator in JupyterHub. You can store your Jupyter notebooks in your project folder. So within the project folder, I assume your collaborator can also access the Jupyter project folder. So you can basically collaborate through that. Okay, another question from Kyle is, can we access the slides? I think I answered that. They will be on this GitHub, and I think there will be an email about it. They will be also posted on the ALCF webpage. Can you share an environment with a collaborator? Yeah, that's a very good question. So that is, so there are different ways to do it. So for example, pip has this pip freeze, or Conda has, I forgot the name, but some utilities where you basically list all the packages that are installed, and then you can share that file with your collaborator, and so you can share the environment, but he needs to install that environment as well. I think there is not an easy way to do it, unless you share your home folder accessible to another user, which may not be a good idea. Okay, another question from when we execute a program on Jupyter Notebook, does it go to complete nodes of theta? Okay, yes, that's a very good question, and this is really important. Anything you execute, any Jupyter cell that you execute, executes on the JupyterHub server, not on Theta. It doesn't see Theta. It doesn't run on compute nodes or mum nodes. But what we can do is we can submit jobs like you do on terminal. I mean, it is like, you can think of it as if you are using the login nodes. You don't run on login nodes, any simulations, right? You need to submit the jobs to the queue manager. Same here. We need to submit the jobs to the queue manager. And again, we will use Cobalt for that, as we use on Theta and Code. Okay, thank you very much for the questions. One more. Can the yes, that's another good question. Can this server become a bottleneck in terms of compute and memory? Yes, right now, as I mentioned, we have a single server with 16 cores and 512 gigabyte memory. While that memory is really good now, but if we have many users, then obviously this will become a bottleneck. And I hope once we see many users, ALCF will hopefully purchase better servers, more servers, and we will have better service. So it all depends on the usage. Yeah, thank you for the question. So I will go to the demo, and you can also speak up during, okay. Okay, one more good question. Is there any access to GPUs? Jupyter Server does not have a GPU right now. So we cannot have, and Theta does not have a GPU, except we have new Theta GPU. But right now we don't have a Jupyter Notebook, JupyterHub for Theta GPU yet. So the answer is no, we cannot access GPU yet. Okay, I will go to the presentation. Do you see my screen clearly, or do I need to zoom in? So let me zoom a little bit more. That's okay, good. This is the, so if you cannot see it, let me know.
That looks okay.
Okay, great. So, okay, let's start. So we will start with a clean environment. So this is when you launch on JupyterHub, and if you have this, if you copy this file, install kernel demo from the GitHub, you can also follow the follow what I am doing on JupyterHub yourself. You don't need to install anything for this part. We are going to show how to install. So generally, I start with all my Jupyter notebooks with these magics at the beginning. So this is very useful, especially these magics, load X, auto reload, and auto reload 2 is very useful, especially if you are developing a code. Because if you are developing a code and you have an import structure, you are importing some module, and you are constantly updating that package. Since Jupyter has caching, it will not import second time. So whatever change you make, it will not see those changes if you don't execute these magic commands. So it is not good for interactive development. So what I do is I add these magics, and then every time you import, it will import the latest version. So this is helpful. Another helpful thing is always check what Python version you are using and what is your environment. And if there are particular modules that you are using, again, check the version and the file of it so that you make sure you are using the right stuff. So you can use this conda list to see all the packages, and there is also this help thing, but this is very slow, so I don't suggest. So for example, if I try to import Balsam, which I'm going to talk about in the last demo, you see that we don't have this module. So we need to follow these steps. So this is basically all the steps that I mentioned. And first part is, let's look at what environment we have. I have. So I have created many demo environments to test. But demo 2 seems available. Oh no, I have demo 2 kernel. So let's go with demo 5. For example, JHub demo 5 is available. So let's change the name to JHub demo 5. You can change it directly JHub demo if you don't have it in your kernel. So you just execute the cell. So this is a Python variable, but as I mentioned, this can be used within the shell magic. So this will take time. So this can take around 5 minutes. So during this time, I will go to, while this is running, I will go to the other demo because this is not, again, this part of demo does not require installation, so we can go ahead. As I mentioned, you can prefix shell commands with like this. These are basic commands. And another cool thing is whatever you execute, whatever the output is, you can assign it back to a Python variable. But let's see what kind of variable is that. If you check it, you will see that it is sort of a list. It is a kind of a class within Python, I think inherited from the list class from Python. So if you want to learn more about what it is, one way is, okay, you can use help as list, or you can do this, which I would prefer. So you can see the details about what it is if you would like to learn. But okay, let's learn by just using it. So for example, if I try to get the content of this README file into this variable, and then if I print that variable, because this README is an object, list object, but it can still be printed in Python, you will see that this README file is converted into a list of strings separated by the new lines. So this can be useful or not, but this is how it works. For example, if you do it same for, I'm listing my files here, you can see all the files now are separated and given as a list, as a Python list. This can be very useful, but if you have a more complicated output, then you will see that it will be separated by fields. So you need to be careful when you are using exclamation mark, and there are actually more sophisticated and better ways of how to execute shell commands, which I will show. Another cool thing is, as I mentioned, you can access your Python variable, you can access your environment variable, or you can just as in terminal execute stuff. with the $sign. And it also extends your tilde as your home directory. And so far we have used just basic Linux commands. So as I mentioned, as I promised, the main chunk is about how to submit jobs. And job submission on Theta is handled with Cobalt. If you are using Theta, you are already familiar with this. But if not, you need to go to documentation, and there are very useful, there are webinars about it, but that you can find information about it. The main key message while using Cobalt is you need to write an executable script to submit a job. So for example, here is just a string. This is a Python string. And then I basically create it and then show the contents to you here. The same thing here I used a Python variable, but I could actually use echo and then pipe it into a file and then do the same thing. So this basically does the same. Then what you can do is we can basically submit this job, and I will try here. I don't know how much time it will take. So if it will take a lot of time, I will use an existing job. But as you can see, it prints the job ID. So this job ID is very useful because all the file output will be related to, it will be prefixed with this job ID. So to see what jobs available on the list, you can use QStat. And here we see that job is queued. And this is not a good sign. This means job queue is long, so this job might take a while to run. But I have a job that is the same job that I had before. Job ID is here. And basically what it will produce you 3 files, one with the Cobalt log, one with the error, one with the output. And we can look at the contents of these files. You will see that Cobalt log have some useful information about the job submission command, when it is executed, the error message. The error message does not necessarily an error, but whatever is printed into the standard error. And here the command is, basically the apron command is printed in the error output. And then you will see the output, hello Jupyter here. So, okay, this is basic usage. You don't need to have anything. Another way, which I would recommend, or I hope you will find useful, is we can basically use some predefined functions. And I use some widgets to make it interactive. So these are all available on the GitHub page. So I'm talking about this easy cobalt.py script. Another cool thing about this is if you have a Python script, you don't need to install anything. You basically need to load that Python into a cell. You can directly copy all the content of the cell file into cell, and then you will execute it. Or alternatively, you can modify your Python path to direct the folder that the files live, and then you can import the modules in that fashion. So this is simple. If everything is a Python script, you don't need any install. And another magic here that is very useful is this load magic. Load magic is basically can load any file on the disk. So for example, I can, to demonstrate another feature, maybe I didn't mention. So when we try to type a file, you see that even without the Jupyter, even without the shell magic, it has access to my files. So this is very useful, but sometimes it prints actually more than what you want, more than the files. But here you see the easy cobalt.py. We can load from here, but let's not do that. Let's do another cool thing. Let's load it from web. So you can put an URL here and then execute. And then, so maybe since the content was here, it may not appear so magic. So let's just create a new cell and run this magic here. You will see that it will run this and then comments the top line, and then you will have all the content here. So we'll have all the files. We just need to execute it again so that all the content is basically now in your environment. So I just deleted that. So let's look at what functions we have available. One function I have is qstat, and you can see how it is implemented here. You can see the source. Basically, it is taking user as an argument, job ID, or you can change the headers that you see on the qstat output, and you can put some extra commands like grabs, and you can define if you want a full detailed information or not. And this is basically done just using basic Python commands, string operations, and then I use popen. So this is another way how you can execute shell commands. And then I have another function. Let's see the content of that. So this one is the interactive version of the qstat. And this is really simple, and this is why I'm really enthusiastic about these widgets. Although you may, some people do not, want to do everything on the command line, some people are more visual and provide some user interface. And widgets provide this in a very effective way, in a very simple way. So here, for example, the only thing I did is I have this qstat function, and then I import this interact menu. With this interact menu, I can basically sort of wrap my qstat function. The rest is basically not necessary. I just modify the name of the button. So this is the signature, and let's see how it works. Oops, I need to enter parentheses. And you see, we have this interface, and now we can check qstat. And now we see that actually the previous job we had has already completed. Another thing about qstat or Cobalt environments, any job that has been done, completed, is basically cleared from the database, so you cannot see it with the qstat. But another tool that I will use, Balsam, will help you to see all the executed files as well, all the previous job IDs. Okay. So another feature we can use in qstat, I can look at actually, I've typed all here, I can see all the qstat. And one thing you can do, for example, I can add to see what is in the debug queue. So you see that what jobs are on the debug queue or not by simply appending this grep into your command. And we can pick up one of the jobs here, put the job ID here. So if you put a job ID, it will be taken the other options are ignored except header. And then you will see detailed information about this job. Another feature is basically very simple way of how you can generate your job script, because as I mentioned, there are different operations. You need to type your job script, and then you need to turn it into an executable. So here, basically, you can do it in using these widgets. You can type the number of nodes you want. You can type the ranks per node, and you can specify the affinity. There can be more logic here, but right now it is just a simple way of doing it. And then you define your executable. And then you will see the output, and you can just copy paste into. It can create a file with that. And if we do iQSub, you will see that with QSub we had many options, like the project. For example, you can type your project here. And one cool feature is you can select the queues, because you need to learn about these queues from the manual, but now this widget basically helps you to see all the queues available. And another cool feature is if you select, for example, debug queue, and if you try to run it on 16 nodes, and if I just click submit here, it will give me an error message. So stating that max number of nodes is 8. Or if you go to default queue, and if you try to submit with 16 nodes, it will also say that error, the minimum default queue is 128. So okay, since I didn't, there's an error message that I need to fix later. But this is basically how you can use iQSub. So for job IDs, for example, I mentioned you that there are 3 different outputs. Here I am looking at this job ID, and we have this tabbed way of looking at the output, which can be useful. This is just another way of using widgets. Another thing is, this doesn't require widgets. You just parse the Cobalt log file, which you may find very useful, because Cobalt log has lots of information. And I can print here information related to timings. And what you will see here is, I think, important, is even this simple echo hello world, hello Jupyter job takes a minute to run. And this is all because the initiation of the compute nodes and then termination of your job. And this is really adding an overhead. And even on a single node, this is 1 minute. And as you increase the number of nodes, that overhead can be larger. So this basically brings us to the point that using a workflow manager like Balsam can be very useful if you want to run many things. Because getting into the queue, getting into the job is expensive. Running, there is an overhead. So within a single job, you can assemble many different smaller jobs, and we will do it with the easy Balsam now. Let's now, do you have any questions at this point? Okay, I will go back to the kernel installation. So we were at this cell, and okay, it took much less than I did before, so around 3 minutes. So we clone the environment. And then the next step is installing Balsam. One thing you can do while installing stuff is you can, if you encounter some problems, you can add -v, which will give you more verbose information. Same for conda install or pip install. In conda install, you can put -v to have even more verbose. So this installation should be rather quick. Yes, it's installed in 15 seconds. And then the last step is we need to install the Jupyter kernel. So just to show you that although we have installed, so let's go back to here. So if we look at the conda environments, we have this demo 5, but we don't have this demo 5 kernel. So now we will basically provide that. Yes. Okay, so we have the kernel installed. After this, you basically need to, you still will not see your kernel here. To do that, you need to either refresh or open a new tab. So by refresh, I mean refreshing the browser, not using the restart button here. So let's okay, so after this is done, we can select now the kernel. Let's see if it is available. Yes, it's selected. Wait for it start, and again check for our environment shows JHub demo 5, and I can import Balsam, and I think here let's do. And then you will see it's we have 3.8 installed, and it is in demo 5 environment. Okay, so with that done, I will go to Balsam demo. And for this one, let's switch to our new kernel. But I need to refresh in here. Now we have demo 5. So, okay, some notes on using Balsam. Balsam is, as I mentioned, automates this HPC workflow. So it's a workflow manager. You can submit many runs, and everything is stored in a database. And there is a service component that automates the job submission or queue submission. And it can also do this load balanced execution. And you can find more info on Balsam in this address. And Misha is the developer, so has provided lots of tutorials and good documentation on this, so you can check out that. So easy Balsam script that I have here is basically implementing convenience functions and interactive widgets just to simplify the usage. So these are the nodes that I mentioned. We can use the load or this. So we can do this. Again, the same thing. And now I have this load Balsam here. So what this load Balsam function is doing, you can check the output, is basically, it is importing Balsam, and if it gives an error, it will give you a nice information about what needs to be done. Gives you Balsam version. And then it is also adding Postgres path. So this is something required to run Balsam. And since it is installed in pip, Postgres needs to be installed separately, but it is already installed on JupyterHub. So you just need to point the path, and this is done here. So this is basically just changing the environment variable. And then we check the version of it. Note that there might be some problems depending on the version mismatch on the Postgres you use on Theta, on Postgres you use on JupyterHub. So that needs to be taken care of. So basically this is a useful function to load all of this. And then the next thing is you need to activate the database, and you need to see your databases. So this is like the Balsam which command that you would use on a command line, but now you can also select from a drop-down list. So you see I have different databases here. Let's pick this number 7, or let's pick this one, which is just for demonstration. And you can look at all the apps in this. And another way of looking at the apps, which I find very useful, is you can see the contents of the app. For example, this is just a simple, say, hello app, say echo hello. And these are all basic apps. But if we go to, for example, another database, and then look at the list, you will see these are more, these are the actual applications that I use, NWCam, TEM, and other stuff. You can see how you can define the name, executable, description. And I will also show you how you can, for example, save apps. But to do that, I want to go back to this demonstration database. And here we can type a name, new app, and then you need to provide an executable. Just for now, we can use sleep. You don't need to even type anything for description, so you can just click Save App. It checks for the sleep app executable and then adds this to the database. So if we list apps again, you see that new app appears with all the content that we have. But okay, this was a useless app and we want to delete it. You can do this like that. So this basically simplifies using Balsam. Otherwise, you need to learn lots of commands to do all these basic operations. Another cool feature, you can list all the jobs that were submitted within this database. You can look at for example, job status. You can filter against the created jobs, finished jobs, and etc. Or you can also see different workflows that we have. I don't have workflows actually different. Or you can separate by the code. And you can add new jobs again by simply filling this and you can select number of nodes from the drop-down list and ranks per node. And again, you can select so you definitely as depth or none. And you can put some environment variables, but they are optional. So we save this job as well. And at the end, it provides you the job ID. So that job ID here you see can be used to get more information about a particular job. So we can see here all the jobs, for example. For example, let's take this job, put here, and then we will see what this job was about. Or if you delete all the filtering goes out and you go back to everything you have. And finally, you can submit jobs. This is, again, you can select the queue, you can select the wall minutes, and but you need to, this is not optional, you need to type the project. So this is basically the demo. We can also submit a test job here just to see the output. First, we need to save and then click submit. And at the end, so now it is submitted basically by the Balsam. So it will try to execute all the jobs that have been put into the database, since we didn't put any workflow filters here. If we put a workflow filter, we can select basically the jobs that we want to run. And we can go back to our QStat app here. And just execute this again. And you will see that, okay, our job has already started running. We can see the information, more information by clicking variables. So you see where it is, where the output directory is, where the error path is. Note that here Balsam actually does not use the job ID for our error and output. No, they can be prefixed with any other thing. How about allows that? And you can see your job ID and other information. And then basically the next steps would be examining your output, parsing the output so that you can run plots. And I can basically show you a real workflow very quickly. For example, I have been running different chemistry calculations, electronic structure calculations, and then I can basically put everything into a data frame. I can collect all my output into a pandas data frame, and then I can try to analyze that data frame and plot it on my Jupyter Notebook. And they can be all done on JupyterHub without copying any data. So this I find very useful. So this is just basic plots, but you can enhance it with widgets, and you can create a dashboard for particular application that you have. For example, another project that I have been working on was on this connectomics project related to mapping the neurons on the brain. And we can do the pre-processing steps by looking at the images on Jupyter Notebook easily. And then we actually run some scaling tests to see how our TensorFlow training is scaled, and then analyze our data on JupyterHub again, and then plot. And basically, these are all the plots that can be published, and actually these results were published, and all the results were generated on JupyterHub. You can create publication quality graphics by exporting into a PDF or EPS. So this basically, I think, concludes the presentation.